Hello, today we have a practical lesson on free fall and we are going to see how some equations work when applied to specific problems. Let's get started. First question. A grapefruit falls from a tree and reaches the ground in 0.75 hundredths of a second. From what height did the fruit fall? At what speed did it reach the ground? Let's write down the conditions of the problem. We know the time for which this fall was made. And we need to determine the height from which the fruit fell and the speed at which it hit the ground. But meaning, of course, the terminal velocity. Here we can add some data, which are not given in the problem, but nevertheless we can guess about them. First of all, of course, is the initial velocity at which this body started moving, and it's clear that a fruit hanging from a tree has no initial velocity and falls without one. And we also know that there's the acceleration of free fall in which this body will fall, which we know as a constant. Let's do some calculations. The first calculation is the velocity of the body. Let's start with it. That is, this body falls from a certain height h. Let's denote it this way. The initial velocity is 0, and the terminal velocity at the moment of fall. We have to find it. The equation of velocity that we can talk about in this case is as follows. If we point the y-axis along which this body is moving vertically downwards, then all these quantities will have a positive sign of projection, and the equation will look like this. We see that we know all the data, we only need to put and calculate the given velocity. Well, and accordingly, after calculations, we get the value of speed 7.36 hundredths of a meter per second. This is the speed we get. Now let's talk about how to determine the height from which the body fell. If we look closely at the height, it's essentially the difference between the initial and final coordinates of the body. And this equation that we're talking about is also known for free fall. Let's write it down. If we move the initial coordinate to the left side, then there is exactly the difference between the final and initial coordinates. It is directly the displacement of the body, or the height from which the body fell. Therefore, this expression can be rewritten in this form. For this expression, we already know everything. It remains only to put the value and calculate. The initial velocity is 0, so this component is also 0. Therefore, we rewrite only the values that have a value. And so after the calculations, we get an answer of about 276 hundredths of a meter. Well, in general, if we talk about the reality of these values, it's quite natural. Figure height of the tree can be about 3 meters. The speed of about 10 meters per second when falling from a height of up to 3 meters is also quite a logical speed. Therefore, for the first task, we got quite real answers. Task 2. During a test drive on a racetrack in a crash, driver David Purley was subjected to the greatest overload experienced by a human being. He decelerated from 173 kilometers per hour to 0 at a distance of 0.66 hundredths of a meter. Calculate the acceleration experienced by Purley and compare it in units of g. Let's do this calculation and see what was the acceleration experienced by this rider during the crash. So we need to determine the acceleration of the body, and we know the initial velocity is 173 kilometers per hour, the final velocity. Once it's stopped is 0 kilometers per hour. and the distance at which the object stopped is 0.66 hundredths of a meter. Meters. We need to determine the acceleration of this racer during braking and compare it with g. That is, we can write the ratio of a to g. We will determine this value a little later when we will talk about the laws of dynamics of body motion, and there we will see just how to calculate this overload, taking into account the forces acting on the body. So the acceleration with which the object moved can be calculated knowing the initial velocity, final velocity and displacement that was made by it. We also know this equation. Let's write it down. This equation is convenient because it allows us to calculate the displacement of the body without knowing the acceleration of the object. Therefore, in this case, we can immediately use it, and the only point to be taken into account is that the acceleration with which the body moves during braking has a minus sign, so it must be taken into account. Let's see what we have in the end. The final velocity of this body is 0 according to the problem condition. Therefore, it remains only to rewrite it, taking into account this substitution. And we get the expression in which just remains the initial velocity of the body and the acceleration with which it moved. We need to find the acceleration of this object. Let's express it from the obtained formula. It will be the square of the initial velocity divided by twice the displacement of the body, of this body. It remains to substitute the value. Here, the only point, we must be sure to say that all the data that we substitute here will be measured in system units, so we must necessarily translate the speed in meters per second. To do this, we must divide the speed in kilometers per hour by 3.6 tenths. This is a quick factor that allows us to do this conversion immediately. Here inside this expression, we'll write it down right away. So the displacement is 0.66 hundredths of a meter. By the dimensionality, of course, we get a meter per second squared, and making the appropriate simple mathematical calculations, we get an approximate answer for the acceleration of 1,750 meters per second squared. And now estimating the ratio of this acceleration to the acceleration of free fall. That is, we can now compare this acceleration with the g value of 9.81 hundredths of a unit, which is approximately 178 units. That is, the acceleration experienced by this racer is 178 times greater than the acceleration with which we fall to the ground. This is a huge acceleration, of course, and actually such loads, a person is actually not ready for them, of course. And so these are the tasks we can consider on the example of the application of the equation of free fall. In future lessons, we will certainly continue to develop this topic on this all until soon meetings. Goodbye.